What if the Big Bang, the moment we've long held as the birth of everything, wasn't the beginning at all? What if our universe, with its sprawling galaxies, blazing stars, and infinite mysteries, is nestled inside the heart of a black hole, a cosmic crucible in a larger reality we cannot yet fathom? Recent observations from the most advanced telescopes, paired with bold new theories, are shaking the foundations of cosmology. They suggest our universe might not be a singular explosion of creation, but a dynamic region of space-time, born from the collapse of a prior cosmos. This possibility, both exhilarating and unsettling, challenges everything we thought we knew about existence. In this exploration, we'll dive into the evidence, unravel the science, and confront the profound implications of a universe that may be a fragment of something far grander. The idea that our universe could exist inside a black hole begins with a startling observation. The cosmos may carry a hidden structure, a subtle imprint of its origins. Astronomers have long assumed the universe is isotropic, meaning it looks the same in every direction, with no preferred orientation. Yet, recent studies of galaxy rotations have revealed a peculiar pattern. When researchers examined hundreds of galaxies from the early universe, they found a surprising asymmetry. Roughly 60% of these galaxies spin in one direction, while only 40% rotate the opposite way. This imbalance, subtle but statistically significant, defies the expectation that galaxy spins should be evenly distributed in a uniform cosmos. The data comes from cutting-edge observations, capturing light from galaxies that formed when the universe was just a few 100 million years old. These are not random quirks or observational errors. The pattern persists across vast distances, hinting at a cosmic alignment baked into the universe's earliest moments. This discovery is no small matter. In the standard model of cosmology, the universe began with the Big Bang, a rapid expansion from an infinitely dense point, with no inherent direction or bias. Galaxies forming billions of years later should reflect this randomness, their rotations balancing out across the cosmos. But the observed preference for one spin direction suggests something else: a primordial influence, a directional force or structure that shaped the universe's infancy. Imagine the universe as a vast canvas, painted with galaxies that subtly lean toward a shared orientation. This cosmic handedness, as some call it, raises a profound question. What could impose such a pattern on the entire universe? The answer may lie not in the Big Bang as we know it, but in a radical rethinking of where our universe came from and what it truly is. Enter the black hole universe hypothesis, a theory as audacious as it is elegant. This idea proposes that our universe is not a standalone entity, but exists within the event horizon of a massive black hole, itself embedded in a larger parent cosmos. In this model, the Big Bang was not the absolute beginning, but a transformative event, a moment when matter and space-time collapsed under unimaginable gravitational forces, only to rebound into the expanding universe we observe today. Picture a star in a distant cosmos, collapsing into a black hole. Inside its event horizon, where physics as we know it bends and twists, a new region of space-time forms. A pocket universe with its own laws, stars, and galaxies. Our universe could be one such pocket, born from the death throes of a prior cosmos, carrying faint echoes of its parent's properties. How does this connect to the galaxy spin patterns? If our universe formed inside a rotating black hole, that rotation could leave a mark on the fabric of space-time. Just as a spinning star imparts angular momentum to the planets forming around it. A rotating black hole could imprint a preferred direction on the galaxies within its interior universe. This inherited spin might explain why early galaxies show a bias toward one rotational direction, a cosmic fingerprint of the black hole that birthed our reality. The idea is not mere speculation, it's grounded in advanced physics. Theories extending general relativity suggest that collapsing matter, under extreme conditions, avoids forming a singularity, a point of infinite density where physics breaks down. Instead, quantum effects, or modified gravitational rules, could trigger a bounce, where the collapse reverses into expansion, creating a new universe with inherited traits. This hypothesis also offers a tantalizing way to address other mysteries in cosmology. For decades, scientists have grappled with the Hubble tension, a stubborn discrepancy in measurements of the universe's expansion rate. Different methods, some based on nearby stars, others on the cosmic microwave background, yield conflicting results, as if the universe's expansion history doesn't quite fit the standard model. A black hole universe could resolve this by altering the dynamics of expansion. If our universe emerged from a bounce, rather than a singular Big Bang, its early expansion might have followed a different trajectory, leaving subtle clues in the data we observe today. Similarly, observations of surprisingly massive and mature galaxies in the early universe, galaxies that seem too developed for their cosmic age, might make sense if some matter or structure was inherited from a pre-bounce phase, accelerating galaxy formation. The black hole universe model also draws support from the mathematics of gravity. In certain frameworks, gravity is described not just as a curvature of space-time, but as a force that incorporates the spin of particles. These theories suggest that a rotating black hole's interior could create a space-time region with a preferred axis, influencing the formation of cosmic structures. The observed galaxy spin bias aligns with this idea, as if the universe itself remembers the rotation of its parent black hole. This isn't to say the theory is proven, far from it, but it weaves together multiple anomalies into a coherent picture, from galaxy rotations to the Hubble tension to the presence of unexpectedly old galaxies. It's a framework that invites us to rethink the cosmos, not as a singular creation, but as part of a vast, interconnected cycle of universes. The implications of this idea are staggering. If our universe is inside a black hole, the Big Bang was not the ultimate origin, but a transition, a moment when one cosmos gave way to another. Black holes, often seen as destructive endpoints where matter and light vanish, could instead be cosmic wombs, birthing new universes with each collapse. This reframes our place in the cosmos. We might be living in a nested reality, a universe within a universe, part of an infinite chain of creation and collapse. Every black hole in our universe could in turn spawn its own cosmos, each with unique properties, laws, and stories. The very concept of a beginning fades, replaced by an eternal cycle of rebirth where universes emerge from the ashes of their predecessors. Yet, this vision of the cosmos demands rigorous scrutiny. The evidence for a black hole universe, while compelling, is not conclusive. The galaxy spin data, based on hundreds of early galaxies, is a strong start, but far from definitive. To confirm a cosmic alignment, researchers must study thousands more galaxies across different regions of the sky, ensuring the pattern holds universally. Observational biases must also be ruled out. Could the way light travels through the universe, or our position within it, skew our perception of galaxy rotations? These questions require meticulous analysis, as the stakes are nothing less than rewriting our understanding of the cosmos. The path forward is clear, even if the answers are not. Telescopes will continue their deep-field observations, capturing light from the universe's earliest epochs to map the rotations of thousands of galaxies. Scientists will also search for relics, primordial black holes, gravitational waves, or other signatures that might hint at a bounce rather than a singular Big Bang. Meanwhile, cosmologists will refine their models, testing whether modified theories of gravity can better explain the universe's expansion and structure. These efforts may resolve existing tensions in cosmology or uncover new mysteries, each step bringing us closer to understanding whether our universe is a cosmic orphan or a child of a larger reality. This journey is as much philosophical as it is scientific. If our universe is inside a black hole, it challenges our sense of uniqueness. We've long imagined the Big Bang as a singular, unrepeatable event, the moment when time and space began. But what if it was just one chapter in an infinite story? The idea that black holes could be gateways to new universes invites us to see the cosmos as a tapestry of creation, where endings are beginnings and destruction is merely transformation. It suggests that our universe is not alone but part of a multiverse, a vast ensemble of realities, each born from the collapse of another. The emotional weight of this possibility is profound. To think that our universe, with its countless stars, its delicate web of life, its fleeting moments of wonder, might be a fragment of a larger whole is both humbling and exhilarating. It reminds us that our quest for knowledge is not just about equations or data, but about grappling with our place in an unimaginably vast cosmos. Every galaxy we observe, every photon we capture, is a clue to a story that stretches beyond our comprehension, a story we are only beginning to read. As we stand on the brink of these discoveries, the universe feels more alive than ever. The patterns in galaxy spins, the anomalies in cosmic expansion, the whispers of a bounce rather than a bang, all point to a reality richer and stranger than we've dared to imagine. Whether our universe is truly inside a black hole remains an open question, but the pursuit of that answer is reshaping our understanding of existence. It's a reminder that the cosmos is not a static backdrop, but a dynamic, evolving mystery, inviting us to look deeper, question boldly, and marvel at the possibilities. The future holds promise and uncertainty in equal measure. As new data pours in, we may find that the galaxy spin patterns grow stronger, supporting the black hole universe hypothesis. Or we may discover alternative explanations, new physics that reframe the cosmos in ways we can't yet predict. Either way, the journey is transformative. We are not just observers of the universe, we are part of it, our questions and discoveries woven into its fabric. Stay tuned as we probe the edges of reality, chasing the truth about where we came from and what we are. A universe perhaps within a black hole, dreaming of infinity.